So what I want to talk about now is a little bit more about how you graph systems of equations. And what we talked about before is how you graph something. And just to be clear, we want to make sure that whatever we have is in the right form. So I'm going to subtract x to both sides. So I have negative 2y equals negative x plus 4. I'm going to divide by a negative 2. And I get y is equal to, this is like saying 1, so 1/2 x minus 2. Now I'm going to do the exact same thing for the next equation. So I have 2x minus 4y equals 8. I'm going to subtract 2x to the other side. Now I still have a negative 4y, and it's equal to a negative 2x plus 8. So I got to divide by a negative 4. What I'm left with is y equals 1/2 x minus 2. So if you see here, if I graph this, I'm going to start the first one at a negative 2, go up 1 to the right 2, and it's going to look something like this. Now if I do the exact same process for the second one, I start at negative 2 and have the same slope. So what does this mean? They're the exact same line, so why would I draw it twice? So if they're the exact same line, what does that mean in terms of my answer? Well, if you take one line and put it right over top of the other one, every point is an intersection point. So every single point is a point of intersection. So there are a lot of different solutions in the way you write this. Is that there are an infinite number of solutions. There's an infinite number of them. Now for this next one, we have it nice and set up for one of the lines. This is already solved. So we have one of these already solved for us. So it's already solved. So that's nice. So now I just got to deal with the second one, which is actually the first equation. So I'm going to subtract x. So I get negative 2y equals negative x plus 6. Divide by a negative 2. And I get y is equal to 1/2 x minus 3. So again, notice here, I solved the first one and I got the exact same thing. I got the exact same line, just written 2 different times. So the question is, how do I write this? Well, there is an infinite number of solutions. It's an infinite number of solutions. So I jumped ahead to the next page, and again, these aren't going to be the exact same line. So what I'm going to do is I'm going to solve each one of these for y. So I'm going to subtract x. So I get y is equal to a negative x plus 1. There's my first line. I'm going to do the exact same thing with the second one. I'm going to subtract 2x. And I get y is equal to a negative 2x. So I'm going to graph these two lines. I'm going to start the first one at 1, and I'm going to go down 1 and to the right 1. So there's my 2 points. The second one, I'm going to start at 0, since it's really like saying plus 0 here. I'm going to go down 2 and to the right 1. So what I have is a line that looks like this, and a line that looks like this. Now it's not to scale, and it'll probably look a little bit different on your paper. What I have is a point that looks about to be right here where they meet. And that's at the point negative 1 comma 2. So there is my solution. It's not the same line this time, it's a different line. The second part of this section I'm going to start by talking about, and I'm going to finish in the third part of this video, is the idea of the substitution method. And the idea for this is that this is my second process. So this is the second process to solving for a system. And the goal is to substitute for any variable. That is solved for. Okay, so what I'm going to do is I'm going to take and go from this in the next video, and I'm going to talk about specifically what I mean by solving for a variable and how you go about doing that in the next video.